Okay, analyzing 38, complete the chart. Radius, let's go ahead and substitute r. Angle, theta, arc length is s. This should be a mini cap that we're working with a formula that you should have memorized. Okay, it may or may not be on your review sheet. If not, here it goes. Okay, so all we're going to do is substitute into this formula. They give us 1. You are working in radian mode. Rule of thumb, they give you radians, you're in radian mode. You cannot use your calculator, so we're not even going to use it. Here we go. So you're in radian mode of thinking. As basically you have r substituting for the first one, and I'm going to write it each time. You have r is equal to 6. You have theta. Theta you're asked to multiply, so theta is equal to pi over 4. And s showing with multiplication. You're multiplying fractions. Rules for multiplying fractions are numerator times numerator, denominator times denominator. So this is going to be 6 pi over 4. I'm just going to put a little invisible 1 here so that you can see it. And then this is your ratio. Even numbers are divisible. So all I'm going to do is simplify it. And this is pretty much a mental math. I'm dividing by 2. They both were divisible by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. And don't forget your pi. Your pi goes on top. So this value goes here. Left to right, top to bottom. Now we are on looking for this. Again, all we're going to do is substitute. Write the formula again. Formulas are designed to substitute into. Okay, substituting this time r. I'm looking for my s. Your r is missing. So s, you have the value. That's 15 pi. The r is missing. So I'm kind of using the commutative property. R times theta is the same as theta times r, because I like the coefficient to be in a different color. And your theta value is 5 pi over 6. Okay, you're solving for r. And what you should have learned about the rule for dividing by fractions or solving for r, you multiply by the reciprocal of your coefficient, which is going to be 6 on a numerator, 5. Right? And whatever you do to the left, you do to the right. Whatever you do to the right, you do to the left. So that's why I wanted that to be in a different color. Same value. Oops. Okay. So now a number multiplied by its reciprocal is 1. So this left side is going to give you 1. It's the right side that you're doing the mathematical concepts. Okay, so dividing or multiplying, multiply straight across, or you could do some what we call simplifying. So simplifying this left side, both of these are divided by 5 pi. 5 pi goes into 5 pi one time. 5 pi goes into 15, 3. So you're going to be left with 3 on the top. Remember, this is 1 on the bottom, so this answer is 18. That goes here, and in the units that they are talking about, and it seems like this is feet. Okay, last one is, again, formula S equals R times theta. Your S is 30. I don't know why I wrote 33. S is 30 equals, your theta is missing, and our R is 10. Solving, divide by 10. Theta is already in radians. You're given that as the preface. So theta, what we're looking for, is equal to 3 radians. 3. You have to know, hey, radians can be a fraction or they can be a decimal. this is what we did. That's it. Okay, and just tagging the order in which I did this in, which was A, this was B, and this is C. Okay, now moving toward identities. Time check. Okay, so I just want to get maximum row. Here we go. All right, these are your basic identities. Your basic identities, you want to try, your goal is to try to rewrite everything in terms of sine and cosine. So this is your hint. I'll bubble it in a color. In terms of, those are how we simplify our basic sine and cosine, x and y. All right, so get this in a nice color. All right, sine is already our pure value, so we're just going to rewrite this as sine over 1 times cotangent. Now these are quotient identities. You should have in room. Cotangent is x over y. X is cosine, y is sine. Now your goal is to only work with one side. So what you're trying to do is just solve the left side. In the end, we need to get cosine squared, or excuse me, cosine. So we're just working here. And then as we work for the next step, you multiply across. So you could see, hey, opposite of multiplication is division. A number divided by itself is 1. So you're going to be left with 1 on the top. And that means if we multiply, I'm going to circle that, because we're going to multiply 1 times cosine, which is cosine. And on the bottom is going to be a 1. A number divided by itself is 1. And so we get cosine. This is it. This is really easy. No drama. There's only 2 steps. 1, 2. Cosine equals cosine. Okay. And you don't even need this 1 if you want to clean that up. That looks nice and pretty. Moving onward, I need to shimmy down. Take this here. Okay. Shimmy some more. Okay. I'm just going to move this up. And here, we're only working with one side. So I'm moving this space, and you either could work with left side or the right side. So you're only working on this left side. Okay, in the end, we have to get this. Keep in mind, this is the double angle formula. Oh boy. Okay, so we're going to have to go back to that double angle formula. First thing you're going to do is your hint. Hint is change this to make sure we understand the math that's involved. I'm going to work with the hint over here again, which is y equals sine x, not 6, and x equals cosine x. Okay, rewrite. I'm doing all this rewriting on the right side, and you have to show it on your paper as well. So rewriting this is going to be y plus x squared, which is equal to y plus x times y plus x. A number, when you square something, it's the product of a number or an expression times itself. We're going to FOIL this out. Reviewing FOIL. FOIL is first. Y times y is y squared. First is outside. Now, because of order, I want to put a coefficient of 1 and put this in alphabetical order, which is going to be xy. And I'll put the 1 here. Okay, now that's your outside. You have to do your inside. Changing the color back to black, enter. Those are like 2 birds cooking. We did outer, enter. Enter is, again, x times y. We're going to make that 1 xy. And then last. Last, we'll look at blue. So these were inner. And last are last in a first term and last in a second, which last would be x squared. Okay, so in the end, you get y squared plus 2xy plus x squared. And then we have to apply our hence. And we should get that this side is sine squared or sine x squared. The square goes before the sine. Plus 2 sine. They have usually put sine first. Cosine of x. So I'll put the x, squeeze them in here. We'll rewrite it over there nice and neatly. And then plus cosine squared x. All right, this is what is going to be the simplification of this side. So writing that nice and neatly, sine squared x plus 2 cosine x, doesn't matter, commutative property, sine x plus cosine squared x. Okay, this is where you revisit and look at your identities. Anytime you see squared, you go to your Pythagorean identity, and this is the basic Pythagorean identity. That sine squared x plus cosine squared x is equal to 1. Okay, I am applying, again, commutative, associative, rewriting. As long as you're adding, it doesn't matter the order. So this 2 cosine x sine x stays. Okay, so now I'm going to get 1. That's your Pythagorean identity. Plus, what was here before? 2 cosine x sine x. Now look at what we have our goal. We have our 1 already. We need to get this sine double x. Hopefully, if we look at your formula sheet, and you have to take the time to actually look at it, and right away, boom, this is exactly the double angle for sine, and you just rewrite it. So now we're finished. 1, and this portion over here, plus is equal to sine of 2x. And we get that this left side is equal to the right, and this is done. So that formula sheet, and again, is crucial. And these are your steps. This is your A, expanding it out, or we already have B, so we have to rename it in terms of 1, 2, and 3. 1, this is your 2, grouping your terms that make a sign. This is 3, so this is 4 steps. You want to write nice and neat so that your work can be evaluated. And this over here is scratch work. Okay, moving on. Here we go. I put these in the middle because I want to make sure you know you're only working with one side. In the end of, we have to prove that the more complex side, the left side, is going to equal to this value on the right side. So you have to know that there's an equal here. Okay, we're rewriting everything in terms of sine and cosine. So we're definitely going to need space, and definitely going to need to show order. Okay, so the first thing I'm going to do is, again, look, you want to try to get sine. One of the things that I could say is you can immediately turn this into sine, or you could leave it alone. Now, if I look at 1 plus cotangent squared, anytime you see squared term, you want to look for a Pythagorean identity. Okay, so I took a snapshot of the Pythagorean identity, and you should see here, we can use this. This is the exact replica of the bottom. Now, because of that, I'm going to leave this in terms of cosecant. Normally, I would go back to sine and cosine, which you could do, but we'll probably do that later. Let's see. And I'm just going to write what that value is, which is cosecant squared of x. Oh, this looks very similar. Okay, factor. We're going to get cosecant x. Factor anything x squared is that expression times itself. Simplify by dividing. A number or an expression divided by itself is 1. We're left with 1 on the top. And on the bottom is cosecant x. Nice. This is your reciprocal function. So reciprocal function means this is going to be 1 stays over. Make sure you respect the original fraction line, 1 over sine. And then 5, shimmying this down a bit. I'll show you everything. We'll have to do this one in the next video. Is going to be, how do you divide by fractions? Takes the numerator, which is 1, and multiply the numerator, 1, by the reciprocal of the denominator. 1 over x is the original. So the reciprocal of 1 over sine x is sine x. And in the end, sine x is equal to sine x. Nice.